atom is the smallest particle of an element that has all the properties of the element. A molecule is a particle consisting of two or more elements combined together in a specific arrangement. Scientists have proven that the atom is composed of smaller particles. From experiments conducted in the later part of the 19th century to the early half of the 20th century, scientists collected evidence that the atom are composed of three types of particles, namely protons, electrons, and neutrons. These components of the atom are collectively referred as subatomic particles. Protons are positively charged particles, and this is the symbol of a proton. It has a mass of 1.672 times 10 to the power of negative 24. Electrons are negatively charged particles. This is the symbol of an electron. It has a mass of 1.109 times 10 to the power of negative 28. And neutrons are subatomic particles that has a neutral charge. It has a mass of 1.675 times 10 to the power of negative 24. The location of a proton is in the nucleus of an atom. Neutrons also can be found in the nucleus of an atom, while electrons can be found outside the nucleus of an atom. The massive part of the atom comes from the masses of the protons and neutrons. Collectively, the protons and neutrons are called nucleons. The nucleons, tightly packed together, form the nucleus in the center of the atom. The arrangement of subatomic particles according to mass from lightest to heaviest is electrons, protons, and neutrons. Among these subatomic particles, it is the number of protons that identify the atoms of an element. All atoms of an element contain the same number of protons in their nuclei. This number is the element's atomic number. While the number of protons is the same with atoms of a particular element, the number of neutrons may vary. Atoms having the same number of protons but different number of neutrons are referred as isotopes. The isotopes are identified through their mass number, which is the sum of the number of protons and the number of neutrons in an atom. Atomic mass or mass number, it is the mass of an atom of a particular element. To calculate the number of subatomic particles in an atom, use its atomic number and atomic mass or mass number. The number of protons is equal to the atomic number of an element. The number of electrons is equal to the atomic number. And the number of neutrons is equal to the atomic mass minus atomic number of an element. For example, the given isotope is N14. N is the symbol of nitrogen. In the periodic table, nitrogen has an atomic number of 7. Therefore, the number of protons for nitrogen is 7. For the number of electrons is equal to the atomic number. But you are going to consider the given charges. So, you are going to subtract atomic number and the charge. In here, the atomic number of nitrogen is 7 minus the charge, which is 0. Therefore, the number of electrons for nitrogen is 7. For the number of neutrons, you are going to subtract atomic mass and atomic number. So the atomic mass of nitrogen is 14 minus the atomic number, which is 7. So the number of neutrons for nitrogen is 7. Next, example number 2. Isotope F19. F is the symbol of fluorine. In the periodic table, the atomic number of fluorine is 9. Therefore, the number of protons is 9. For the number of electrons, 9 minus the charge, which is negative 1. So 9 minus negative 1 is 10. So 10 is the number of electrons for fluorine. For the number of neutrons, you are going to subtract atomic mass and atomic number. The atomic mass of fluorine is 19 minus the atomic number, which is 9, so the answer is 10. Therefore, the number of neutrons for fluorine is 10. And for the last example, Mg24. Mg is the symbol of an element, magnesium. In the periodic table, the atomic number of magnesium is 12. Therefore, the number of protons is 12. For the number of electrons, magnesium has an atomic number of 12 minus the charge, which is positive 2, so the answer is 10. Therefore, the number of electrons for magnesium is 10. And for the number of neutrons, magnesium has an atomic mass 24 minus the atomic number, which is 12, so the answer is 12. Therefore, the number of neutrons for magnesium is 12.